So 4.3 is vectors. Vectors are kind of another way to look at lines. They're a way to demonstrate lines when you're talking about how far they go and what direction that they go in at that point in time. Okay. Why is this not working? There we go. All right, so vectors involve two things. Okay? One is the direction, and two is the magnitude. The magnitude is the length of it, essentially. Okay? So quantities involve magnitude but no direction are just called scalars. So if you look over here at the left, there is a line segment. It would be a ray if you want to go back to your geometry days. Okay? It has one solid point and it goes forever in one direction. Now, we will only talk about certain points of this, but you will still put an arrow in the end. We don't necessarily make it a line segment. The magnitude would be that segment, but just like any line, it kind of goes on forever. Okay? So, looking at it, based on this one, you have two different points on it. One is called your initial point. That's where it starts at. Two is your terminal point. That would be where it ends. Initial, terminal. Where it starts, where it ends. And it would be an array format of PQ right there. It'll be called vector PQ. And then the length of the segment is called your magnitude. So anytime you have pairs of vectors, there's four different things that can happen. One, you can have equal vectors. Equal vectors have same direction and the same magnitude. Second one, you can have two vectors that have the same magnitude, so they have the same length, but they're going in slightly different directions. You can have the same magnitude in opposite directions, which is on the bottom left there. Same length, their directions are just completely flipped. And then you have same direction, different magnitude. Okay? Now, I keep talking about magnitude. How do you find magnitude? I'm going to scroll up just a little bit here. The magnitude is written like this. If I'd have vector u, for instance, I would go double bar on each side of it. That would be the symbol for magnitude. That is saying the magnitude of vector u. And to find the magnitude or the length of that line segment, you'd have to use essentially the distance formula. Okay? So to find the magnitude of something, you'd have to have points x2 minus x1 squared plus y2 minus y1 quantity squared. Okay? That would be the magnitude. It's back to the distance formula. And remember, you square it to make things positive before you put it in the square root. Okay, so even though it feels a little bit repetitive to square then the square root, that's why you make things positive, because you can't have a negative distance. All right, so let's scroll down here to that first example. So it says, show the two vectors equal. You must show two things. You must show they have the same direction and the same magnitude. So in graphed on the coordinate plane, I have those two right there. I have negative 2, 6 is the terminal, and negative 5, 2 is the initial. The second one, 2, 2 is the initial, and 5, 6 is the terminal. So we want to show that they are equal. To show that they're equal, two things. Direction, which is slope. 2 is magnitude, which is distance. I don't know why 2 was written twice there. But. All right, so let's show that this guy are in fact equal. So looking at this first one, I'm going to use this. This would be vector 1. This would be vector 2. Okay? So vector 1, let's find the slope. Now the slope, if you remember back to your algebra 1 days, what's my slope formula over there? Belinda, you can see it. Read it off for me. Slope formula, not slope formula. There you go. Y2 minus Y1 over X2 minus X1. So for this first one, I'm going to say this is 0.1 and this would be 0.2. So slope would be 6 minus 2 over negative 2 minus a negative 5. What's 6 minus 2? 4. What is negative 2 plus 5? Okay, so that's the slope of line 1. Vector 1 will be 4/3. Let's check the second one. Second one, I'm going to have 6 minus 2 over 5 minus 2, which is also going to be 4/3. Okay, so our slopes are the same. That's good. Boom. Now, we got to check the magnitude. Okay, I just gave the magnitude formula above. It's just the distance formula between the 2 points. So let's go with a magnitude of 1 here. Magnitude of 1, I'm going to have the square root of -2 minus -5 quantity squared plus 6 minus 2 quantity squared. So here I'm going to end up with 3 squared plus 4 squared. What's 3 squared? 4 squared. So 9 plus 16, which is going to be 25. Square root of 25 would be 5. All right, so that's the magnitude of vector 1. Do it again for vector 2. So 5 minus 2 squared plus 6 minus 2 squared. 5 minus 2 is 3. 6 minus 2 is 4 squared. You get 9 and 16. So you still get the same square root 25 or 5. Right? So is that the same? Absolutely. All right, so those two vectors would be equal. Now notice, they occur at 2 different locations. It doesn't matter that they're 2 different locations. It still has the same direction and it has the same length. What's that? Uh-huh. You hate it? Well, it's back now, unfortunately. At least it's not a new formula though, right? All right, so that was just kind of looking at vectors and kind of show them how to show that they're equal and those types of things. All right, next thing we have is called scalar multiplication. So if k is a real number and v is a vector, kv is called scalar multiple of a vector v. Basically, all it does is take the length of it and double it. If you have multiplied by 2. If you multiply by 3, you triple the length of it. All right, this is essentially all that goes on for that. Now, next thing is adding 2 vectors. So if you want to add 2 vectors together, what you essentially do is take the first vector, this will be my first vector, wherever the first vector ends, the second vector you would just tackle in the end. Okay? So this is the first vector, this would be the second vector. So at the end of the day, this is where we started at. Start at the initial point of the first one, and then we would end at the terminal point of the second one. So our resultant vector would be there. Okay, so what shape? Triangle. So that's how this really fits in. All right, so the sum of u and v, or u plus v, is going to be called the resultant vector. This guy right here would be the resultant vector. For the difference of 2 vectors, it's very, very similar. Okay, in this case, though, you would start them at the same place. So this would be, we'll say this is v, and this is u. If I want to subtract it, it's the opposite of 1. Okay, so just even by definition here, negative u is a scalar multiplication of u and -1. So I would do the same thing as do with the addition. I would leave v, start it at its initial point, go to terminal, and then that would be negative u. I just flipped it around. I changed the direction, flipped 180 degrees. That was now be negative u. So this over here would be my resultant vector of v minus u. And again, what shape does it make? It makes a triangle. So this would be the resultant vector in that case for the subtraction. This is the resultant vector for addition. Questions so far? Now, we haven't seen any equations of what a vector equation looks like. We've just seen pictures of them so far. So if we want to represent vectors in a rectangular coordinates, we'd have vector v starting at the origin, and it goes to point AB. you would write it like this. This is vector form here. B equals AI plus BJ. Okay? I and J are your two letters. Good?
Yeah, fine. Yeah, they're inappropriate.
I don't know why it's so funny.
BJ. Yeah, I mean. BJ and
Those
BJ.
initials. All right, so we got I and J. Anytime you're going to have this, you're going to have something that equals something I, something J. Okay? So for instance here, just look ahead real quick. B equals negative 3J plus 4. That should be 3I. This should be I. Make that change right now. I plus 4J. Negative 3I plus 4J. All right, and what happens is your A term, or whatever's with your I, that is your horizontal change. The J term is going to be your vertical change. Okay? Let me just flash down to this example. I'm just going to make it look easier. If I have this, vector V is negative 3J, negative 3I plus 4J. I would go left 3, 1, 2, 3, and up 4. Okay? 3 is my horizontal, 4 is my vertical. So basically, I just went to point negative 3, 4. Okay? And then your vector would start at 0, 0, and go to there. So that there would be vector B. Okay? Now it says let's find its magnitude. Right? Well, the magnitude, look right here at the bottom of that box up there. I have the magnitude of V, is this. Well, if it starts at 0, 0, I don't really have to use the distance formula the whole time. I just have to take A squared plus B squared. Okay, because I only have a single value. It starts at the origin, I have a single value. I don't have to do subtract 0, 0 off of both of them. So let's do the same thing for the one we just drew. Vector V, square root of, what's my A term? Negative 3. My B term? 4. Okay, negative 3 squared, it's going to be 9. 4 is 16. Square root of 25. So what's the magnitude of this guy? 5. With me so far? Okay. I don't think this lesson isn't really crazy. There's not a whole lot of crazy concepts, but there's a whole bunch of definition type things. All right, moving forward. This is just the official representation of vectors in rectangular coordinates. If it has the initial point and a terminal point, you would use that, like we just said. I is the horizontal, J is the vertical. Now you can add and subtract them. We talked about those with the resultant vectors. We're going to look at this algebraically, how to add things together. Basically, if you're adding them together, add like terms. Add the I terms, add the J terms. Okay? Just like if you had X's and Y's and Z's. Combine like terms. For scalar multiplication, all you have to do is multiply each term by that number. So right there, I have 4 different things. I have V plus W, V minus W, 3W, and 2V plus 3W. And I have vectors V and I have vectors W. So we're just doing some vector algebra, really. So we're going to do the first one and the third one together. You guys are going to do the other two. So the first one, I have vector V, just here, vector W. I'm going to add those together. All you have to do, guys, is combine like terms. So I'm going to have 5 plus 6, I, plus J's are 4 minus 9. So what's 5 plus 6? 11. What's 4 minus 9? Negative 5. Boom. 11i minus 5j would be v plus w. Okay, I'm going to flip over to 3w. So if I have 3w, I have to essentially take 3 times everything. So 3 times 6 is what? 18. 3 times 9? There we go. That would be 3W. Take 30 seconds to a minute and do the other two. All you got to do is combine like terms. Just be careful when you subtract. You'd have to subtract. Almost make each one in W a negative first. Last one, make sure you do your multiplication before you do your addition. All right, we good? Okay, so what'd you get for V minus W? Anybody? Negative I plus what? I got 13. Let's look at it. So V is going to be 5 minus 6 I plus, we're going to have 4 minus a negative 9. Missed one negative sign in there, I'm guessing. Okay, so I had 5 minus 6 is negative 1, and 4 plus 9, which is 13. Who got that? Okay. Second one, 2V plus 3W. So what I'm going to do first, I'm going to multiply them. So 2V, I'm going to end up with 10I plus 8J. Okay. And then plus 3W plus 3 times 6 is going to be 18. And 3 times negative 9 is going to be negative 27. Combine them. 10 and 18 is what? Good, 28. 8 and negative 27 is negative 19. How many of you guys got that one? Okay, the math isn't crazy hard, is it? All right. About 2 more things to take care of here. Next thing we have written on there is a zero vector. Zero vector is just a vector with no length and no direction, so it exists, but it's really nothing. Yes, basically. All right, unit vector. Now, remember we had unit circle, right? A unit circle was a circle with a length of how far all the way around? What was it? Okay, 2 pi the whole way around, but what was the length of each individual radius? 1. Okay, so what do you think a unit vector has? A length of 1. Okay, it has to be a length of 1. So what you would do, you would use this more as like a reference vector or something like that. Okay, so unit vectors is defined as a vector whose magnitude is 1. So what you would have to do is you would take your vector and divide it by the magnitude. That will get you a vector with a length of unit 1. So we're going to take this guy right here. We're going to find the unit vector in the same direction as V. then verify that the magnitude is 1. So I have my vector right here. I want to find the magnitude of it. So if I find the magnitude, I plug those two numbers into essentially the distance formula. So I'm going to have the square root of 5 squared plus negative 12 squared. All right, 5 squared is 25. 12 squared is 144. So that's going to be 169. What's the square root of 169? 13. Okay, so this vector here has a magnitude of 13. I want it to be 1. So what I have to do now is I want to go v over the magnitude of v. My vector is right above here. V equals 5i minus 12j. I want to divide every term by 13. 5 over 13i minus 12 over 13j. That would be my unit vector related to v.
Why did they make them I and J?
I don't really have an answer for that one. I wondered the same thing too. So they look very similar too when you write them, don't they?
Yeah.
And that's I try to when I do my eyes, I try to make a tail to the right because J has the tail to the left, you know. All right, so let's make sure it has a magnitude of 1. So I'm gonna plug this in. I'm gonna have 5/13 squared plus negative 12 over 13 squared. Okay, so this is going to come out, square everything, so 25 over 169 plus 144 over 169. Add those two together, what do I get? 169 over 169, which is 1. Square root of 1 is 1, so we're good. All right, so you guys are probably sitting there going, Mr. Thomas, why the heck are we talking about vectors after we just use sines and cosines, right? It's a valid question. Emma, I know you're thinking that, aren't you? All right, I can see them wheels spinning. Uh-huh. So let's bring some sine and cosine back into it. So the next two things we're going to do is we're going to take these and we're going to do two application problems here. So you want to write a vector in terms of its magnitude and direction. So let v be a non-zero vector if theta is the direction angle measured from the positive x-axis to v, then the vector can be expressed in the terms of the magnitude and direction angle as vector is the magnitude cosine of that, and then the magnitude of the sine of that. We're going to use it here. All right, so wind is blowing at 20 miles per hour in the direction north 30 degrees west. Express its velocity as a vector v in terms of I and j. All right, so we have a bearing here, don't we? Probably want to draw a picture. Okay, so I have north 30 degrees west. Am I going to be top left or top right? Top left. Okay. And it would be a bearing of 30 degrees, so I'd have this would be 30. Agreed? Now, that total angle is not 30 degrees, is it? What would the entire angle be? This is 90, and this would be 120. There we go. We want to start our positive x-axis like normal. Okay, so that bearing would be 120 degrees. You all right with how I got that? All right, now anytime you have something like this, the wind's blowing 20 miles per hour, or you have so many pounds of force, that is your magnitude. Okay, that is the how long it is. So this here, 20 miles per hour, that is going to be my magnitude of v. Okay, the magnitude for this vector is going to be 20. Now we have everything we need. We're just going to plug it right into that formula that we just gave us. So to find this vector, we would have vector v is equal to magnitude of v cosine of theta I plus magnitude of v sine of theta j. Okay? Plug in what we know. We got a magnitude of 20. We have the cosine of what angle do we just find this vector was at? 120. We have cosine of 120, and then I plus 20 sine of 120 j. All right, you can do, we'll do this if you're using your unit circle. So the cosine of 120 is going to be 1/2. Sine of 120 is going to be root 3 over 2 j. All right, then I'm going to have negative 10I plus, so that should be 10 root 3 j. So that would be the vector that we're describing here when the wind is blowing 20 miles per hour in the direction north 30 degrees west. Up here, this would be root 3 over 2, yes. Questions? Let's get one more problem today. All right, so last one. Two forces, F1 and F2, of magnitude 10 and 30 pounds, respectively, act on an object. The directions of F1 is 20 degrees north, 20 degrees east, and the direction of F2 is north 65 degrees east. Find the magnitude and the direction of the resultant force. Express the magnitude to the nearest hundredth of a pound and the direction angle to the nearest tenth of a degree. A lot going on there, right? So let's think of it like this. If me and Taylor are up here and we're pushing a box, okay? So say, stand up here, boys. Pushing it at the same time. All right, so stand kind of like 90 degrees from me.
Right.
Yeah. There we go. Okay. Now, if we have a box in front of us, okay, and we're both pushing it, all right, who's probably stronger? I was going to say Taylor too. But. All right. So if I'm pushing it this direction and she's pushing it this direction, but we're pushing at two different forces. So we'll say for this that I'm stronger. Okay. The box is going to go that direction, but it's also start moving that way. Start moving that way. It's also going to end up going in this direction too. Correct? Yeah. Because we're both pushing that direction. We're pushing on it. It's going to move that way. But if I'm exerting more force than she is, it's also going to start going. My direction is going to overtake her direction. Does that make sense? Okay. It's going to be the same thing here. You go ahead and see. This here, if we are walking in separate directions, all right, think if you have a rope on you. You guys ever done the thing, the track or football where you put the rope around your waist and someone holds you back?
Yep.
You know what I'm talking about? Okay, say we have that, we're running side by side. All right, so then me and Emma are trying to run different directions. We're running different directions. If we have different amounts of force, what's going to happen? I'm probably going to pull her closer my way, right? That's what we're talking about here. This is resultant force. I don't know, she might have run me over too. I don't know if it's possible. She probably would have tried to trip me though. Wouldn't you, Emma? Huh? Yeah, you would. All right, so for this one, let's draw a picture. Okay, so the first one, we have a force of 10 pounds, and it would be in the direction north 20 degrees east. So we'll say that this is it. That's 20 degrees, and it has 10 pounds. 10 pounds of force, and that's our F1. Now, if we're talking about vectors, and we're also talking about that pound exerted, that force exerted is your magnitude. We talked about that last problem, right? When we said about the wind. So if this one is 10 pounds, F2 has how many pounds? 30. So it's actually going to be 3 times longer. Okay, if you want to draw it in graphical form. So this one would be at north 65 degrees east, and it would be about 3 times as long if we were going to draw that. So that's 65 degrees. All right, because this has 30 pounds of force, and this is my F2. You guys with me so far? Now, we're going to find what's called the resultant force. The resultant force would be basically adding these two guys together, essentially. So if we have a force here at 10 degrees, obviously this one's the stronger one, correct? I would basically take this force and tack it onto the end. Okay? So then that would be tacked on here. That would be the same as F1. So now my resultant vector, I'm going to draw this in a different color. It's not just a different color. So basically it's saying it is this force plus this force. This is how much force you would have. This is how far you're going to go, what direction you're going to go in. Okay? Now, you can't just say I'm going to have 40 pounds of force because guess what? We're pushed in two different directions. Just like we said when I used the example with me and Taylor up here, we're pushing it against it, but we're also pushing that way. Okay, so we're not going to get the full amount of strength out of it because part of it's going to be fighting each other. All right, so first thing we got to do, we got to find the vector for the first one, we got to find the vector for the second one, and then we'll add them together. Okay, so go F1. We don't have a vector, we have a bearing and we have a force. So like we just used above, we're going to take the magnitude of it. Magnitude of the first one is going to be 10. The cosine of the angle plus the magnitude and the sine of the angle for J. Now I'm looking at 1 here. I have to go back from my x-axis. If it was 20 degrees off of north, what would this distance from here, what would this degrees here be? 70. Okay? So that would be 70. That's the angle I'm going to use for this first vector. Boom, boom. Because we have to go from your origin. Origin is the positive x-axis. Okay? All right. So 10 cosine of 70. Punch that in the calculator. I get 342 I plus 10 times the sine of 70, 940 J. Okay? So there's my vector for F1. F2. This one is 30 for a magnitude. Cosine of an angle plus 30 sine of the angle. Let's look back and see what this angle is. So F2 had that bearing that was 65 degrees off of north. What would this angle here be then? 25. Good. So be 25. So that's the angle we want to use for this guy. So I'm going to have 25 here and 25 here. Same thing. I'm going to bang it into the calculator. 2719I plus 12.68J. So there's my two vectors that I have drawn up here. Vector 1, or F1, is 3.42I plus 940J. Vector 2 would be 2719I plus 1268J. Now I'm looking for this resultant vector. I want to find out how much force it has and in what direction it's being pushed in. So let's add them together. So we'll just call this F. F is going to be 342 plus 2719 I plus 940 plus 1268J.
What number is in front of
30? That one? Okay, combine them. I'm going to have 30.61I plus 22.08J. That there would be my vector. That would be the vector that's in yellow there. Now, if I want to find the magnitude is going to be how much combined force those two forces would have in the direction I just found. I would take that. I want to go the magnitude of F is going to be my I term squared, 3061 squared plus 2208 squared. And then I just plug that into a calculator, get 37.74 pounds. So because we are not pushing or pulling in the same exact direction, therefore we're losing some of our force that we're exerting. We lost what? A little over 2 pounds of force because they weren't pushing in exactly the same direction. But we do know the direction it was being pushed in, and that was the vector we just found. Questions? There will be some homework on this. Which one's which?